And welcome everybody. It's an exciting time for space weather. We've got two significant CMEs on the way. That's coronal mass ejections, and we had an X-class solar flare. Of course, we'll cover it. You can see it right there. We'll be bringing it and lots more information as well here from the Smash News Network, least busted name in news. Hey there, congratulations on realizing the channel exists. That's the past 24 hours, and there's that X-class flare. It happened right about 1700 Universal Time. Today, on December 14th, and we're expecting two CME impacts. I think this one might be moving a little bit more slowly than some models, but expecting one to arrive tomorrow and another to arrive on the 16th. So Friday and Saturday, expecting significant coronal mass ejection impacts. Here we've subtracted the 193 angstroms to show just ionized helium by itself. The Solar Dynamics Observatory's AIA instrument featuring 304 angstroms. Here's the equatorial zoom, and yowzers. A big uptick in the radio flux also came in the past 24 hours, and we see multiple prominences there on the eastern limb, which would be screen left. Multiple large prominences rising, an indication that more active regions are about to pop up over that eastern limb. And we've got lots more imagery to show you as well, folks, so make sure you stay tuned for all of that. It is another banner episode of the Daily Space Weather Show. There is our full disk view. And again, lots more solar imagery coming, folks. Here is December 13th and December 14th to date. A little bit of growth there in the northwestern limb. Besides that, mostly stable here. And that's major growth in terms of likelihood of solar flares. The likelihood of solar flares continues to rise here, so it has not expired by any measure. Additional X-class flares are indeed possible, especially in that northwestern limb. If you noticed yesterday's thumbnail and title, yeah, that's called forecasting. It is a thing that can be done, believe it or not. So yeah, two CMEs on the way, folks. And the following are paid endorsements. If you enjoy the content, press the like button. If you're new to the channel, press subscribe. Get the world's most comprehensive daily space weather show delivered directly into your YouTube inbox. Press like, subscribe, share, etc. Visit our links. You can find them below the video in the description. SmashOmash.com is the homepage, and welcome to the Neo Renaissance. If you want additional content, additional alerts, and so forth, become a member of the Smash Team at SmashOmash.com/Smash Team. Massive crown prominence kicking off here. We'll get to that a little bit later in the video as well. SmashOmash.com/Smash Team. There's a bronze, there's a silver, there's a gold. There's a gold annual paid-up subscription thanks to our Smash Team members. You are partially responsible for the existence of these videos. Continuing on. Today's featured product is, and it makes a good Christmas present for your favorite project manager, or maybe even for your least favorite project manager. Pick two. You don't get three. It's either fast and good, in which case it's expensive. Fast and cheap, in which case it's bad. Or good and cheap, in which case it's slow. So pick your choice. You don't get all three. No job is fast, cheap, and good. So understand this project management fact. Would you like it expensive? Would you like it bad? Or would you like it slow? Those are your choices. That's all you get. Pick two. Lots of other products there. Now 38 total designs offered on the Redbubble shop. Also linked below this video. Save up to 50% on stickers. Are you a sticker person? Well, there's plenty on our site. Do you want to get involved in the channel? Would you like to ask a particle physicist a question? Well, you can ask a particle physicist a question by visiting smashomash.com/forum. Right in there's a general science forum. If you scroll down, you'll find the Ask a Particle Physicist segment. If you'd like to ask a question, it's free. You want to get involved? You have a question that you've been asking? Well, ask Eugene the Philosopher via our channel. Every Friday we produce a video including that segment, Ask a Particle Physicist. And there is your particle physicist. So make sure you subscribe to his channel as well, Eugene the Philosopher. His latest is Compete, Don't Criticize. In other words, have an alternative theory if you don't like an existing one. That's always a wise move. Eugene the Philosopher. Make sure you subscribe, or else. You can also find our Hemp Lucid link below the video. Perhaps give the gift of wellness this year. And don't forget to enter the promo code SMASHOMASH10. SMASHOMASH10 will save you 10% on checkout. So save some dough on your Hemp Lucid order. HempLucid.com. Enter the promo code SMASHOMASH10 to save 10%. Thanks to everybody who has picked up items. And continuing on to our Amazon shop, we've added some new things there. You can find things like Stream Decks and more in the new gift ideas list. Multiple different lists there to perhaps do some last-minute shopping. Amazon.com/shop/SmashoMash. And again, don't forget to press the like button if you enjoy the content. Thanks to our new YouTube subscribers. And let's move on to get to volcanoes. It's volcano time, and I want to know what's erupting. What about you? Krakatoa starts out our list as it explodes. It is producing a 4,000-foot plume of volcanic ash, flight level 040 over the Sunda Strait. Krakatoa! 11,000-foot ash plume over Merapi, located on central Java, Indonesia. 11,000-foot ash plume. Bromo. Bro, don't bro me, bro. Too many bros are saying the word bro too many times. In the 90s, we used to say dude every other word. Now it's bro. Bro, dude, dude. Don't say bro, dude. So bro, much dude, bro. Because it's too many dudes and bros. Seismic activity there underneath Bromo on East Java. Dacono exploding, flight level 080. Santiaguito exploding, flight level 140. Fuego exploding, flight level 150. Sangay exploding, flight level 200. That's a 20,000-foot ash plume, by the way. Revenador exploding, flight level 150. Not sure about Sabancaya or Ubinas. Please do not pole vault the caldera. Next, moving on to seismic activity. So there are the past 90 days in a convenient bar graph form. Here are the past 24 hours. We'll call quakes of a 5 or greater magnitude. Kicking off the list today with the North Atlantic Ridge. They're kind of right in the tropical central Atlantic Ocean there. A 5.0 occurred at 6:52 Universal Time this morning. East Pacific rise at a 5.5. That was way down south near the Southern Ocean. That is where the planets got some tectonic motion. 9:29 Universal Time this morning. So pretty seismically calm here. Argentina had a 5.1. That was at nearly 200 kilometers estimated depth and at 14:57 Universal Time this afternoon. And then Mexico had a 5.0. South Sandwich Islands had a 5.4, only about a half an hour later. Then another Guatemalan quake not far from the Mexican one. And then Northern Mariana Islands had a 5.3. Fiji had a 5.0. That was at nearly 600 kilometers estimated depth. And that's the end of the list. So let's get back to some more space action. There are the past 24 hours from SDO. 171 angstroms, the house favorite wavelength. How sweet it is. Good times. Massive filaments rising in the east. And 2 of them headed toward Earth. Yeah, 2 CMEs, coronal mass ejections, are imminent. The second one, I'm saying we might get as high as a KP 8.33 from that one. NOAA tends to disagree. We'll get to it. And before we get to things like coronal holes, let's take a look at some stats here, like the 10.7 centimeter radial flux, which is now all the way up to 155 solar flux units now. So for 10.7 way up from yesterday, a big increase in the radial flux. Typically associated with sunspot number, it is now way up here. So a big uptick there in the radial flux. And the radial flux now popping back up above the 81-day average. So no real surprise there, as we are not yet at solar maximum. So you're going to expect to see this rise until about September of next year. That's seems like a reasonable estimation to me. Next, a space weather enthusiast dashboard, and once again, tomorrow night, so Friday night into Saturday night, we may see geomagnetic storm conditions. NOAA is expecting those CMEs to arrive in rapid succession, so they may even overlap a bit. But that's a space weather enthusiast dashboard. That's NOAA's forecast. And next, let's get to the Enlil spiral. So there's the Enlil spiral. Again, 2 CMEs there. The first one expected to arrive sometime around midday Universal Time tomorrow, and the next one a little bit earlier than that on Saturday. So we'll have to see what happens. It can be pretty tough to estimate the velocity of a CME that is headed directly toward Earth. And there you can see the modeling. 2 CMEs in succession. The second one, a little bit more properly earthly directed. And then a possible combination of them happening. So that's NOAA's forecast. And here's NASA's forecast, not yet modeled by NASA. So probably by tomorrow's daily space weather video, we'll have a NASA forecast. It looks like the first one NASA has missing to the west for the most part. So there you go. NASA expecting that to miss to the west, and it looks like the southwest. So often we do see a vastly different forecast from NOAA versus NASA, and this is no exception to that. Next, Earth's magnetic moment from space. We have had some geomagnetic unrest in the past 24 hours. No storm conditions, but got close. The fields have dissipated in their strength a little bit, also their strong negative BZ component. So that's the last 4 hours of Earth's magnetic moment from space, magnetohydrodynamic pressure. Here's magnetic flux density from ground level, Earth's magnetic moment from the ground. Changes to Earth's B field, geospace delta B. And the units of magnetic flux density are nanotesla. There you can see perhaps the most likely places to see the aurora in the past 4 hours. KP index currently at 1.33. KP 1.33 is the average of global geomagnetism. And let's move on to see if we see any aurora over Iceland. So we've got a bunch of webcams queued up here, and I don't think we're seeing any aurora at the moment. Things are looking calm, if not foggy. So we are seeing some indications of foggy conditions there over Iceland. Anyway, solar wind is next. There's the ACE. The ACE showing about 300 kilometers per second for the solar wind speed. Solar wind density here about 1.5 protons per cubic centimeter. So quite slow and quite diffuse at the ACE. At the Discover, a lot faster and a little denser. So about 4 protons per cubic centimeter at Discover. 435 kilometers per second for the solar wind velocity. A very different solar wind regime there, measured by the Discover versus the ACE. Both orbiting the Lagrangian point 1, about 1 million miles in between Earth and Sun. GOES magnetometers here showing some spiky readings there. And we might see some perturbations here continuing in this. We're expecting some pretty wild gyrations in the GOES magnetometers. They are measuring the Earth's magnetic field from the outer Van Allen belt area. They're orbiting at about 23,500 miles of altitude there. The GOES 16 and GOES 18, the geosynchronous satellites. They are in a near equatorial orbit. The M's and N's stand for midnight and noon local time for the satellite. Next is our top view ecliptic plane field plot, and Earth is going to be in a magnetically indecisive sector. So Earth just snapped into a South Pole sector, and it's going to snap right back into a North Pole sector here, perhaps just in the next few hours. Or we may see some additional sunspot activity. So that may be an indication that we're going to see growth of the sunspots in the northeast That would be my best guess, but it's getting pretty chaotic here at the moment, folks. As we approach solar max, this is becoming less and less effective at having predictive value. It has to do with where the polar fields are located. I'm not going to get into the gory details of it. Here's our line of sight ecliptic plane field plot. And we are seeing magnetic indecision to Earth's east on the closest star. So you'll see quite significant gyrations happening over there also. Over on the left side of those images there, some significant magnetic indecision. Next, our line of sight field plot. And that's one of the most definitive data sets you could possibly have of the closest star there. It shows the sun's B field in blue, polar fields in red and green for south and north respectively, and the photosphere magnetism in grayscale, which brings us to coronal holes. So that's the coronal hole environment. It looks like we had a polarity switch over there. Nope, just a south pole coronal hole. So let's let that get to the last frame here. There you go. So the south pole coronal holes here. So this is south. Hepme. So this down here, this is south, I guess. And then up here, this is south. And then around here, we've got north pole coronal holes. So again, a little bit chaotic right now as far as the polarities of these things. That is the current scenario. Another 24-hour video from Solar Dynamics Observatory. Great view of filamentary reorientations happening there associated with that flare. I thought I had a zoom in. Hang on a minute. Nope, today we just have the full disk view for 211 angstroms. So that brings us to sunspots. And so no major uptick in sunspots, but a major uptick in the radio flux. So a prime example of how sometimes sunspot number and radio flux diverge from each other. Almost the exact same sunspot number as yesterday. Maybe gained a couple of sunspots. If so, it's barely any, right around the average here at about 120 sunspots. That is the current Royal Observatory of Belgium. And the flare probability monitor here indeed showing high likelihood of large solar flares in that northwestern limb. So there you go, no surprises to our regular viewers there. A significant chance remains for X-class solar flares happening. A 1 in 3 chance. That's a pretty high chance of X-class flares, folks, up here in this northwestern limb. Exciting stuff. Exciting times for space weather. And let's continue on. Here come sunspots from SDO magnetogram. And a prime example of how you don't necessarily have to see major changes happening in the photosphere magnetism for a large flare to happen. You'll barely even see anything happen there. Again, around 1700 is when that X-class flare happened. You might expect wild gyrations happening in the magnetic fields of the photosphere, but that's not what happens at all, typically. An indication that the flares are happening well above the photosphere. And here's SDO Continuum for the same period, a 24-hour video. Next, perhaps the moment you've been waiting for, the section with flares, and we're seeing a little proton event happening here. It's not a major one so far, but it is still rising perhaps. So we are seeing bigger variations there happening in the proton flux. A little bit of a proton event associated with one of those flare events. Those are relativistic particles that have made it all the way to Earth at a very rapid speed, a significant percentage of light speed. So there's the flare profile. Again, that X-class event happened just after 1700 Universal Time. 1704 is, I believe, when peak flux was. 1704 for that X 2.87. Something like that. Can I get a little closer? Looks like an X 2.87 class flare to me. And here comes some serious money shots. So there's 131 angstroms, one of the best wavelengths through which to view flare activity. That and 94. And don't worry, we've got them both and then some. So there's 131 angstroms. Once again, another 24-hour video. And that is one of several money shots for the day. Dag. Just when you thought those M-class flares were big, the X-class flare shows up and you're like, dag. What's that? You want an even closer view? All right. We can accommodate that. So, would you like some more wavelengths? We can accommodate that. Here's 94 angstroms as well. Not half bad. We've also got 193 plus 335. And what's great about 193 is it shows you a lot of the underlying filamentary behaviors. And before we get to filaments, let's take a look at a star chart. There's what's going on overhead. And since Cassiopeia shows up in today's daily space weather content, that's what we've focused on. That's what's going on overhead right now, Lehigh Valley, Pennsylvania. Cassiopeia, up there high in the sky near our zenith. And next, a little solar system forecast for you. Here's where things are today. That's where things will be in a week. We will have a gibbous waxing moon by the solstice, as we are in the darkest. Welcome to the darkest 2 weeks of the year. The darkest weeks. Hopefully not the darkest 3 years, if you know what I mean. It's not funny. Anyway, here's the astronomy photo of the day. It's Cassiopeia A, which is a near-infrared nebula. It's a supernova remnant. So lots of heavy elements in there. You're seeing at least hydrogen and oxygen, but lots of other heavier elements likely in there. Of course, the interesting thing about supernovae is that they all contain a star in the middle of them. Cassiopeia A is the strongest radio source in the constellation Cassiopeia. And one of those bright blue stars is what is illuminating most of that material. I suspect it's this one in here. That one looks like it is the central star here. I suspect this one might be in the foreground. But that's some fantastic imagery there for you. Let us know in the comments what you think of that. A great close-up of a supernoval remnant there. Cassiopeia A, a supernoval nebular remnant. Perhaps containing the ingredients for the next Apple phone case, which shatters like glass even though it's made of titanium because reasons. apod.nasa.gov if you want to check it out yourself. That's a pretty sweet supernoval remnant. Next, CMEs. And there are some unfortunate things going on with CMEs because we've got some missing data, but it wasn't enough to prevent us from forecasting those impacts. So here are yesterday's CMEs. That's 92 frames from yesterday. Not super helpful. You're going to be wanting to look at today's frames, so let's get to those. Here are 66 frames from today, and guess what? Those do not include the halo eruption. That's slated to arrive on the 16th. So not there. You're not going to see it here either, because we've got a bunch of missing data on the LASCO coronagraphs. Suboptimal, yes, I know. You're not going to see it here either. However, you will see it on stereo A. So let's switch to that. So there is the raw imagery on the left, difference imagery on the right. And again, that CME, you're going to see that coming out around 1700 Universal Time. Here it comes. Wait for it. And there it is. That is a prime example of an earthly directed CME. So more of the ejecta will miss to the southwest than strike Earth, but it is a partial halo. So expect some fireworks. Fingers crossed for a KP 8.33. I think it's going to be coming a little bit later. I think it's going to show up Saturday night, but we'll have to see what happens. CME impact. Make it 2. Imminent. And here we'll show filaments before we show filaments from the ground-based observatories. So there you go. There's the SDO. Fantastic views of filaments. And again, multiple new active regions rising there in the east, as well as crown prominence happening as we create the video. Expect nothing but more and more action for the next about 9 or 10 months, folks. So great times for space weather here. Some activity kicking off, and let's take a look at, here are ground-based hydrogen alpha images from Cerro Tololo, Chile. And let's just zoom in here for a brief moment so you can see what happens when the flare occurs. Oftentimes when a solar flare happens, folks, we'll see a coronal mass ejection just pop off. There's no filament a lot of times. And this is a prime example of there's no real filament to see there. It's just like layers of the sun's surface just peel off. And that's many, many times do we see a major CME happen with no filament. So oftentimes these filaments eject, and oftentimes we see an ejection with no filaments. So just a little bit of insight into that. We'll also show the grayscale imagery. There you go. There's Cerro Tololo's grayscale imagery. And look at those massive prominences there rising in the east. Pretty sweet. And before we get to bonus features, check out this crown prominence. That is a good one. That is not going to be earthly directed. It is somewhat on the far side. And there is the full disk view, complete with timestamps for your viewing pleasure. And it's time to get to bonus features. First bonus feature is satellite charging hazards. We ain't got none. It's clear sailing. No surface or internal charging hazards for satellites. Goes electron flux here, kind of low, and you can expect it to get erroneously cratered once again when CME impacts show up. Expect more of that, if not even lower levels in the coming days. There's the 1-year graph to contextualize the relativistic electrons. You can see near the bottom of the range. And here's the forecast model. NOAA expecting further downticks. I tend to agree. Moving right along to the ionosphere. The F-layer is the layer we'll be showing, the bridge between Earth and space. Feel free to pause the video on this frame if you're not familiar with distances in kilometers. Here is the F-layer's vibrational frequency. And we are expecting to see quite a bit of low-frequency anomaly here on this. So let's take a look at the anomalygram. That's anomaly in megahertz from a 30-day median. And a little bit more red than you may be used to seeing there. That includes some geomagnetic unrest. So no real surprise there. as the ionosphere is affected by space weather, unlike the troposphere where all of your weather occurs. Anyway, there's the latest image, 2300 universal time for the ionogram, and there's the anomalygram for the same time, 2300. We'll also show the wham! Last Christmas, we didn't show this, but this year we will, so you don't get pissed. This year, because it's so cheery, we'll show you the ionosphere nowcast. There you go. Maximum usable frequency on the right and anomaly. Total electron content and anomaly on the left. What more could you want? The wham! The whole atmosphere model. The global ionosphere nowcast. To quote Nick Burns, a company's computer guy, "You're welcome." We'll also show the total electron content. And here you have it. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model depicting the most likely places for GPS errors. And it looks massively erroneous. So I'm just going to skip ahead and cover the latest intensitygram and latest magnetogram. So here are the sunspots that are continuing to have a likelihood of producing X-class solar flares. And that is a magnetically complex sunspot indeed. Now it is still beta gamma delta class. And it's a strong beta gamma delta class, which makes it a strong contender to continue to produce large solar flares. Here's the full disk. And here comes our meteorology segment. Meteorology. Here we go. We're starting out with sea surface temperature anomaly and ocean currents showing the North Atlantic. Some very cold water up there in the North Atlantic. And the Gulf Stream continues to make its way all the way up to Iceland and Ireland. So that's sea surface temperature anomaly and ocean currents. Let's show the whole planet while we're at it. There's the Atlantic. The Southern Ocean. The Indian Ocean. The mighty Pacific. And the Arctic. Continuing right along, clouds and fog over the Americas. The shortwave radiation map shows clouds and fog even at nighttime. Since clouds emit radiation, infrared radiation, 3.9 micrometers is the wavelength. And here is this system moving north out of Texas into Oklahoma, into Kansas, Nebraska, etc. It's moving north by northeast. And that is the U.S.'s strongest weather system. Next, our precipitation type map, and we are having some New Mexican and some Coloradan snowfall right now. Also Washington, seeing some snow, also Oregon, and of course parts of Canada. Precipitation type, one of the many layers you can see on windy.com. Here's our weather.gov map. Weather.gov, if your location is lit, head to the National Weather Service homepage, weather.gov, and get your weather warnings. Those are too many counties to cover, but here come some forecasts. 72-hour forecasts, I might add, of the GFS model. So there it is, 72-hour GFS forecast. Like we said yesterday, a very strong system is going to form here over the Gulf and then move up the East Coast, starting out with, obviously, the Florida Panhandle. So heavy weather here. Going to start sliding up into the Carolinas in the next 3 days. Heavy rains certainly coming to the Florida coast. Next, accumulated positive snow depth change in inches. The same model, 72-hour GFS. So only a little bit of snow coming in the next 3 days. And temperature anomaly forecast is next. Some very warm temperatures here moving from the Great Lakes states Also, eastern Canada going to have some exceedingly warm temperatures. That's a GFS 72-hour temperature anomaly forecast in degrees Celsius. Expecting some temperatures up to about 25 degrees Celsius above normal. Very warm weather over there. Last but not least, the jet stream, which is the real culprit for most of your temperature anomalies and your weather patterns moving from west to east. It's a 250 millibar winds for the GFS 72-hour model. That is largely the culprit for your major scale weather patterns. Continuing on, we've got lightning. Not a lot in the U.S., though. South America, different story. Brazil, huge waves of lightning down there. So we did have a few strikes here in the last couple of hours, but since then things have calmed down, it looks like. Here we go. Only about 100 strikes per minute at the moment. And let's close this thing out with Doppler radar. There are the strongest storms. Currently west of Wichita, and it looks like Wichita is being missed by that precipitation. We'll briefly show the full 50-state view. There you go. There is vertical motion in the air column for the entire U.S. At least all 50 states. There are the lower 48. Clouds and fog. Fingers crossed for clear nights for the U.S., folks. And there is water vapor. So hoping for some clear skies because we could see some major aurora here. Friday and perhaps even Saturday night. Here's your recap. U.S. Doppler radar. Once again, clouds and fog. Lots of low clouds over the western Atlantic. And last but not least, water vapor. And that is where we will close things out. Thanks for tuning in once again to the Smash News Network, least busted name of news. I've been your host, Dan, a.k.a. Smash and Mash. Don't forget to visit the links below the video. Thanks to everybody who's tuned in. And in the meantime, until tomorrow, I'll have been your host, Dan, a.k.a. Smash and Mash, signing off. And may that solar wind be at your back while I go back to the bunker. Whoa!